Hello, good day to you. Today, I want to talk about System Activity Reporter, or otherwise known as SAR. System Activity Reporter is a tool that can help you to collect performance statistics about your system or over a period of time, maybe in the past, especially in the past. That is historical data about your system. There are a lot of performance analysis tool, but a lot of them just gives you all the information at a particular point in time. But SAR will allow you to, you know, learn about the performance of your system over maybe in the past 1 week, in the past days, in the past minutes. So it helps you to have an historical understanding of your system, of how it behaves. So you can go back in time and understand uh, how your system was behaving at a particular point in time. So SAR is part of the Sys Start package. You can install it by with your default package manager, like so. I am on a Fedora system, so I'm using DNF install Start, but I already have it installed, so it will not be installing anymore. So you can install it with your default package manager, Start. So the definition of SAR itself is, collect, report, or save system activity information. So it collects system activity information over a period of time so that you can, go back in time and understand how your system behaves. So SAR uses this tool called SADC, System Activity Data Collector, to collect uh, the the data. That is the backend tool that it uses. So you can do a man on SADC and to understand what SADC is. So this is what SAR uses, to collect the information at the back end. So SAR comes with two major tools, SA1 and SA2. So when you install SAR, there are two major tools that comes. The first one is SA1 and SA2, and both of them are if in form of a cron job, so a cron task. So if I go to my cron jobs, uh, cron dot not okay. So yeah, sorry about that. I am on a federal system. So on a federal system of it doesn't use the cron the cron jobs. It uses the timer. Fedora is based on system D. So it has, the timer, for these two tools, the SA1 and SA2. So both of them are, tools that operate, with the help of a cron job. So the SA1 collects data every 10 minutes. It runs every 10 minutes. It generates the SA report, which is a binary file. It is a binary file, so you cannot uh, look at it, with a text tool. But there's also SA2. SA2 will summarize the reports each day. It runs at the end of the day, and generates a text file. Generates what is called a SAR report, which is a text file each day. So the difference is, SAR1 runs every 10 minutes, generates a binary file. SA2, SA1, SA2. SA2, runs every day, once a day, and generates a text file. So another directory that you need to keep in mind is the varlog sa. So let's look at varlog sa. So varlog sa is the directory where the this tool sa1 and sa2 keep their reports. So if you look at these files, you see there are some file that has SAO1, SAO2, 803, like that, and there are some that are named SAR01, SAR03. So basically, the essays are binary files. So and this essay, the SAR are text file. So you can look at some of the text files. For example, you can use less on SAO2. Oh, sorry, it's a directory. Uh, oh, sorry. I am not yet in the directory. So you see, so this is an example of the essay, the SAR file. So it is a summary of everything for a particular day. So there are information about CPU performance, about the memory, about the disk I/O, about a lot of things. So the SAR files are generated by SA2, while the SA files are generated by SA1. So that's the difference. If you look at what kind of file is SA01, so it is a binary file, so we cannot read it. So if we try to read it with less, see, it is a binary file, we can't read it. So but there are tools, we can use tools to read them. So that is that about SA1 and SA2, and also the directory where all the reports are kept is varlog sa. So on Ubuntu systems, the config file that you want to check out is etc default start. Then you have to enable the SAR operation. On CentOS system, the config file that you want to check out is etc sysconfig start. So for example, I am on a Fedora system, so I will look at etc sysconfig start. So you see, this is the the config file. So the directory where the SA files are stored are this. This is where it is specified, and the compression program to use, to compress if compression is needed is XZ. SADC option. Like I said, SADC is the backend tool, for generating this report. So the options that you want to pass to it, compression maybe after how many days, and history. So this is on the Fedora system. So, but on a Ubuntu system, it will be different. So, like I said, the SA1 and SA2 are cron jobs. So on Ubuntu system, you find a file like this, etc cron.d start. But on a Fedora system that uses systemd, you find these files, the etc systemd system start.service.once start collect.timer. So let's look at that file. So this is how it is. So basically, on systemd systems, now this is the new way of doing cron jobs. The dot timer system files. So systemd unit files. So you see the unit, it says run system activity accounting tool every 10 minutes, and it said timer on calendar, that is every 10 minutes, it uh runs the program. So the other one, which is, so this one is for SA1. The second one is for SA2. So the SA2, it runs once a day, to generate a report, a summary of the report. So let's move forward. So basically, let's go through some of the things you can use, some of the options available, to read the report. So ordinarily, you can type the SAR with an help command, maybe to get some help. So like I said, if you remember, I said the SA files are generated, they are binary files. So to read them, you can use SAR to read them. So let's say we want to, yeah, okay, and the other one is the version, or dash freeze, or the version, to know the version you are running. So for example, let's say we want to learn about CPU usage. So if we run CPU, that is uh, dash dash u for CPU usage. So this gives us, so you see the date here. So this is for today. This is for the CPU usage uh, data for today. So basically, you have things like uh, this is on all CPU, a percentage utilization in user space, nice, utilization in the system or the kernel space, IO weight, the stolen time. Stolen time is, that is still is, if you are running a virtual machine on this machine, then the idle time. So you see that on this system, my system has been idle. The percentage of time it's been idle is actually like large. So you can see, I'm able to see historical data about my system. And let's say I want to look at data for yesterday. So you can do -1. -1, tells SAR to go back one day. So this is CPU usage for, so you see, this is what I did, -1. This is the date of yesterday. So you see, um, basically the CPU, uh, you know, data and statistics for my system yesterday. So if I want to know if my system was behaving funny yesterday, I can know, I can go back in time, I know. So for example, if you look at this particular time, so at 9 p.m., I think this is, I will say this is when the CPU was doing a lot of work at 9 p.m. yesterday night. So that is for dash U. So also the next one is for dash Q, load average. So load average, gives you an indication of the things that are running on your system. If I mean the wrong queue, the amount of threads maybe that are trying to run on your CPU. So you see the load average. Ordinarily, if you use a tool like Uptime, if you run Uptime will give you load average for I think 1 minute, 5 minutes, and 15 minutes. But SAR will help you to see, even go back further in time, to see the load average. So that is load average. And also you can apply the minus, maybe -2. So -2 will go back 2 days. So this is will be for like 2 days ago to understand my load average 2 days ago. So the next one I have is SAR-R. So SAR-R is for memory. So memory usage. So this is my memory time, basically footprint, memory footprint for today. So you can see that the percentage of memory used, has been greater than 80 most of today. So being in the 90% range, that means I'm using a lot of memory. So you can see the free, the available, and the use. And another option that can help is uh, with the dash dash human. So with all these options, you can specify dash dash human. So basically to give you some of the figures in more understandable way, so you can see um, that, for example, on average. So on average, I have 700 megabytes free, 4.2 gigabyte uh, available, and 6.9 gigabyte used. So that is on average. That is how my system has been performing. So also the next one that I have here. So another one that I would like to show is maybe dash this option dash S and dash E. So what the dash E dash S and dash E means is I can specify the range of time. So for example, if I say uh, I want to see the memory usage between starting from 9 a.m. So this is start from 9 a.m. I want to see the memory usage starting from 9 a.m. So or let me restrict it more a little bit. Let's say I want to see the memory usage starting from 11 a.m. So this gives me, I can basically focus on a shorter amount of time. And if I want to get a range and say hand, I want to see maybe memory usage between 11 a.m. and 12, let's say 12:30 p.m. So this gives me the memory usage between 11 a.m. and 12. So this is this option dash S dash E. So that gives you uh, a way to reduce what you want to see. And we can even go back in time. Let's say I want to see between 11 a.m. and 12 a.m. yesterday, so I put -1. So this is about yesterday between 11 and 12:30 p.m. So another one is dash A. So basically dash A, yeah. So dash A is for all. Dash A I have here is for all. So it, if you want to see everything, all the statistics, the memory, the CPU, the IO, everything. But I don't think that will be too much. So let's use dash Q. Oh, sorry, dash Q. Sure. Okay, yeah. So I think I've done dash Q. But one thing you can do is you can use a particular file. So let's say um, I want to look at data from a particular SA file. So let's say I put SA10. So this looks at this particular file. You can specify a particular SA file, with dash F, like this. So another thing that may be of interest is context switches. So context switches on your system, maybe uh, you want to have an idea of how much context switching is going on your system. And I think let me see. Yeah, okay, context switches. So the next one that you may also be interested in is uh, network. So let me look at my network. One of my network device here is EMP4S0. So I can specify SAR-N and dev to specify the network device. So hold on, let me see. This should give me. Let me look at the man page for that. Onto dash N. Okay. Dash N. Let's do dash N and use all. Okay, so all gives me about all the network interfaces. So you can, if you want to know about all your network interface, but I think I should be able to specify. Let me see. Should be able to specify a particular device. Oh, sorry. That's interesting. Yeah, I should be able to specify a particular device, network device for. So if I want to see basically the network statistics, the packet received, packet sent, the errors. Let me try again. I don't know what's going on here. Interesting. Dev. That's interesting. I'm supposed to be able to specify the network. And be the interface. Okay, maybe I'll go back to that. So another thing that may be interesting is the block IO. So to understand, uh, the block IO or the read writes, going on your system. Another one may be page, page fault. So maybe you want to look at page in, page out. So you can combine all of this with some of the other options that we have looked at. Human. So some of the options that we have looked at before. So page in, page out, page faults, major fault, page free, and so forth. So So it is a really good tool to look back. So some of the other ones that I have here, be interesting. So let's look at SAR dash A. H, uppercase H is for huge pages, and to look at a particular disk. So SAR dash D. Oh, sorry. SAR dash D. In dev SDA. Okay. SAR dash D dev. So basically, this is look at the performance regarding to your particular disk, to the disks on your system. So these are like some of the options and other options that you can combine. You can look at the man page, for more ideas. You can look at the man page for more ideas. But the usefulness of this tool is the fact that it helps you to go back in time and understand the performance of your system, or at least it helps you to look at a range, a period of time, and understand how your system is behaving. Yeah, so I'm still a little bit surprised about this the one with the network. I'm trying to look at. Let me try that again. Okay, yeah, this gives me basically the oh okay, dev. So I'm surprised I can't specify, but I can look at each of the network devices that I have. So basically, this is the one I use the most. So I can look at the received packet, the sent packet. Let me put dash dash human here. So it gives me in bytes. So the receive, the send, and percentage interface utilization. So this is the one I use the most. So the utilization of my network interface is not very high, but maybe in a high performance environment, you might see a lot more data here. So this gives us information about our networking, which I think is one of the a very important um, subsystem. So I think that's all I have. So to recap, SAR is System Activity Reporter. To install it, you use the systat. Um, these are the two major tools that are being used: SA1 and SA2. SA1 operates every 10 minutes. SA2 operates once a day. This is the directory where all the data goes. This is about the config file. So the cron job, like I said, these two, the SA1 and SA2, they operate based on cron jobs. So on system that use the cron, you look at this file, it's a cron.d systat, but on system that use system D, like Fedora that I am on, you see this timer being used, and some of the options we covered for memory, CPU, network, disk, and other things. So thank you for watching. Let me know your comments, any thoughts, ideas, subtraction, addition, or wherever. Thanks for watching. Bye.